Welcome to the video where I'm going to be describing how to solve free response question number 2 of the 2015 Calculus BC exam. So what we're given, it's a vector analysis problem with calculator, and we're given that the velocity function, or the velocity of the particle in terms of x prime and y prime are equal to cosine t squared and e of t over 2, which is the same as that, respectively for x prime and y prime, and that when t is equal to 1, the initial position, well, the position at t equals 1 of the particle is 3, 5. So, part A is asking, find the x-coordinate at the position of the particle at time is equal to 2. So, we are looking for x of 2. Now, if we remember the fundamental theorem of calculus, we can find that using our initial equation here, that x of 1 plus the integral of 2 to 1 of x prime of x, x prime of t, which is given by that in the what was given in the equation, is going to equal to x of 1 plus x of 2 minus x of 1. So we'll be left with just x of 2 through the use of the integral. Now, since this is a complicated function to do an integral, luckily we have our calculator. So if we plug into our calculator x of 1, which is 3, plus the integral from 2 to 1 of cosine t squared dt, we will get that x at time equal 2 is equal to 2.557. Pretty quick, as long as you can remember the fundamental theorem of calculus. Alright, so right here we have the beginnings of part B of number 2, and it is asking that on the interval of 0 to 1, when is the tangent line to the particle the slope of the tangent line to the particle equal to 2. So we know that we're looking for when dy over dx is equal to 2. So for vectors, dy over dx is equal to y prime for x prime, which is equal to e to the 0.5 t over cosine t squared. And we're looking for when it's equal to 2. So if we plug this equation into the graphing part of your graphing calculator and set y equal to that, you can also, once you have that graph set up, you can look for when on this interval the y value is equal to 2, or you can use the calc function on your graphing calculator and set when y is equal to 2. You can find what the x value, which for us would be a t value, what the t value is. That's the way I do it because I find that the solve function is a little bit too sketchy. So when y is equal to 2, using the calculation function, I found that t was equal to 0.84. So that worked out well. Alright, for part C, it's wondering at what time is the speed of the particle equal to 3. So, speed is much different than using the velocity for vectors because that is it's a single variable varying either thing. So, the speed function when using a vector is equal to y prime squared plus x prime of t squared. So those are the two ways you can write them, but this is the speed function. So, plugging in the values that we have, we will get cosine squared t squared plus e to the t, and we are looking for when that is equal to 3. So using the same method of plugging this equation into the y equals whatever for the graphing part of your graphing calculator and finding when the y value is equal to 3. That method really works well for this problem because this will be terrible to figure out. Yeah, You plug this all in and you find that when your y value is equal to 3, your t value is equal to 2.196. So that's how you can find at what time the speed of the particle is equal to 3. So for the final part of this problem, for part D, it is asking for the total distance traveled by the particle from time t is equal to 0 to 1. So when you're dealing with distance rather than displacement, the distance is the total distance traveled, like it said. But with vectors, because it's talking the particle's position on the graph, it can dip into the negative side and just hang out there for a bit, but it's still traveling distance, as you could see. So to figure out that distance, we're going to want to use the speed function that we used in part C. So the distance from 0 to 1, sorry, 0 to 1 is going to be equal to the integral from 0 to 1 of the speed function. So root cosine squared t squared plus e of t dt. So this is just the same speed function that we used in part C, just now we're doing an integral of it. So using your calculator, you can just plug this in and you'll get that your distance is equal to 1.595. You could just put units because it did not mention how far or what the units were on this graph, so just units will be perfectly fine. You'll get another 2 points to your problem. That's been my time. Thank you so much.